Ancient amber unlocks lost Amazon secrets, rewrites rainforest history.
Imagine walking through a humid forest where resin drips down tree trunks, preserving tiny creatures for millions of years.
We're about to explore the first South American amber deposit filled with insects and plants, mysteries uncovered.
Stay tuned as we bust myths, debate our finding, and share puns that will make you groan.
Welcome to our dive into 112 million-year-old amber from Ecuador's Genoveva Quarry, revealing an ancient rainforest before today's Amazon.
We'll peel back resin layers to meet ancient flies, beetles, wasps, caddisflies, and early angiosperm leaves, connecting insects, plants, and climate.
And yes, the elephant in the room. Our hosts are AI-generated, but the research comes from real scientists and studies.
So settle in, subscribe, as we journey back to witness the dawn of the Amazon and see how it inspires us. Our story begins in the Genoveva Quarry in Ecuador's Napo province, where the Pollen Formation harbors early Albian amber deposits. These amber layers, dated at around 112 million years old, formed in low-lying lagoons along the western margin of Gondwana. Geologists identified 3 amber-rich levels with thousands of pieces, including a unique 70-centimeter thick slab, rich in root lumps. Root amber pieces grew kidney-shaped underground when resin oozed from tree roots and hardened within water-saturated soils. Aerial amber forms stalactite-shaped drips from branches or trunks that hardened in air, rarer but containing insects and spider webs. Fourier transform infrared spectroscopy and biomarker analyses matched the amber's chemical fingerprint to Araucarian conifer resins. Peaks at 1719 inverse centimeters and a carbon isotope ratio confirmed that the resin came from Araucarian relatives like monkey puzzle trees. The Pollen environment was a low-lying humid forest with braided rivers and lakes, lacking evidence of paleofires in these layers. Cyclical Palynology reveals 42% pteridophytes, 37% angiosperms, 13% netophytes, and 8% conifers in surrounding vegetation. This composition shows a transition from gymnosperm-dominated forests towards angiosperm-rich communities during the mid-Cretaceous. Delicate leaves of early angiosperms with reticulate venation and elliptical shapes were found preserved in thin silt layers above the amber. The deposit's location in Gondwana helps bridge the biogeographical gap between Northern Hemisphere amber and ancient South American ecosystems. Such sites were previously rare in Southern Hemisphere, making this discovery a landmark for understanding early Amazonian biodiversity. Water-saturated soils, perennial rivers, and abundant conifers created ideal conditions for resin production and preservation of tiny organisms. Even though root amber is abundant, insect inclusions are mostly in aerial pieces, showing distinct preservation biases. Palynological records include pollen grains used to date the deposit precisely to early Albian, around 112 million years ago. No evidence of charred material or microcharcoal suggests a moist environment, with little to no wildfires during resin deposition. The deposit formed near a climatic gradient across Gondwana, with higher precipitation in western margins and drier interior basins. This gradient may have influenced plant communities and resin production, hinting at early ecological diversity in South America. Altogether, these contextual clues help us imagine a lush wetland forest brimming with ferns, cycads, enetophytes, and emerging flowering plants. It sets the stage for our data dive into creatures entombed inside these amber pieces, from tiny flies to veined leaves. Understanding this background also underscores the rarity of the discovery, as resin rarely preserves such diverse fossil assemblages.
Among the insects entombed in this amber are biting midges and early mosquitoes like Archaeostrocanops, which reveal early blood-sucking lineages. These dipterans also pollinated early plants, reminding us that flies were more than pests. They were ecosystem engineers from the start. Beetles preserved include fungus feeders such as Tetratomidae, carrion feeders like Histerids, and slender soldier beetles, illustrating diverse feeding guilds. Some beetles bore into wood, others grazed on fungi or preyed on smaller insects, hinting at complex decomposer networks within early forests. Tiny parasitoid wasps, related to today's Stigmaphronidae, appear with elongated ovipositors, pointing to early host specialization and intricate life cycles. Their presence indicates that parasitoid behavior evolved by the mid-Cretaceous, predating many flowering plants and shaping insect communities. Caddisflies with hairy wings signal the existence of freshwater streams, where their larvae build cases of sand and plant fragments. Whiteflies and plant hoppers show up too, leaving delicate wing impressions that mark early herbivory on leaves of angiosperms and ferns. Aerial amber pieces occasionally preserve spiderwebs, complete with trapped insects, offering a snapshot of predator and prey suspended in resin. These webs prove that spiders were active hunters, weaving sticky silk to capture early flies and beetles among conifer branches. Other microhymenopterans, including fairy wasps, demonstrate that even the tiniest parasitoids thrived in this prehistoric rainforest. Palynology reveals the pollen mix: 42% pteridophytes, 37% angiosperms, 13% gnetophytes, and 8% conifers. Myth-busting time. Not all amber is golden or clear. Root amber here is opaque, kidney-shaped, and often lacks inclusions. Another myth. Amber rarely contains dinosaurs. This deposit holds mostly millimeter-sized insects and plant debris, not prehistoric monsters. Many people think amber comes only from the north. This southern hemisphere site proves resin flows from Gondwana too. Resin didn't just drip from branches. Root resin oozed underground, producing the most abundant amber pieces in this deposit. Fourier transform infrared spectroscopy shows peaks at 1719 inverse centimeters, confirming a conifer source for the resin. Biomarker analysis detects diterpenoid compounds like abiatane and labdane, consistent with Araucariaceae resins rather than angiosperms. Several amber pieces contain leaf fragments, cuticles, and even trichomes, offering glimpses of plant macrofossils alongside insects. Delicate leaves with reticulate venation record some of the earliest angiosperms, supporting the rise of flowering plants in South America. Netophyte and fern remains remind us that these ancient groups still dominated forests, even as angiosperms were emerging. Whiteflies feeding on leaves illustrate early plant-insect coevolution, as herbivores adapted to new flowering plants. The presence of caddisflies implies calm streams or lakes nearby, supporting aquatic larvae and wetland food webs. Beetle diversity reveals multiple ecological roles: fungivores breaking down wood, predators controlling pests, and scavengers cleaning up detritus. Parasitoid wasps reflect complex food webs, where insects parasitized other insects, shaping population dynamics long before mammals appeared. Altogether, the insect guilds show that early Amazon ecosystems were already complex, with producers, consumers, and decomposers interacting. Another misconception: amber can't tell climate, yet the lack of char and presence of aquatic insects indicate humid, fire-free conditions. Whiteflies show delicate tubular mouthparts and wax-producing glands, features that let them exploit new angiosperm hosts. Dipterans here have slender proboscises and long legs, traits that help them visit flowers and avoid sticky resin. This data reveals behind this research combined geology, palynology, entomology, and geochemistry, demonstrating the power of interdisciplinary collaboration and collective curiosity.
Students from Ecuador, Argentina, and Europe participated, highlighting the global effort to uncover and study these tiny fossils and share them broadly.
Such cooperation ensures that discoveries benefit local communities and contribute to worldwide scientific knowledge, rather than being exported quietly.
As with many fossil sites, illegal collecting poses risks, the team worked with local authorities to protect the quarry and its heritage.
The high quality of the amber invites new technologies like micro-CT scanning to reveal internal structures without damaging specimens.
Future expeditions hope to find more pieces and perhaps vertebrate remains, though expectations remain grounded in insect-rich reality.
In the end, this amber is about curiosity and respect for deep time. Each piece is a treasure worth protecting. We've seen that the Amazon's roots stretch back at least 112 million years, showing deep continuity and resilience in tropical ecosystems. This deposit teaches us that early rainforests were already complex and wet, challenging myths that the South was barren or dry. Insect diversity reveals that pollination and parasitism evolved long before bees, reminding us that small creatures drive big ecological changes. Angiosperm leaves with reticulate veins show flowering plants were diversifying early in South America, bridging a key gap in plant evolution. Conifer resin from Araucaria relatives produced the amber, highlighting how gymnosperms nourished this ecosystem and still survive today. Palynology confirms a mix of ferns, gnetophytes, and flowering plants, reminding us that communities transition rather than abruptly replace each other. Traces of aquatic insects and absence of charred wood paint a portrait of a humid, fire-free forest teeming with life. These insights underscore the importance of conserving modern wetlands and rainforests, which still harbor unseen species and carbon stores.
The story of amber teaches us to preserve fragile things. Our world today needs that care too, so support organizations that protect habitats, study fossils, and communities. Want more behind-the-scenes content? Visit our website and newsletter for interviews with researchers, bloopers, concept art, and extra puns not seen on YouTube exclusively there. If you're hungry for knowledge, consider becoming a member. Perks include early access, vote waiting in polls, and your name in the credits of future episodes. We acknowledge the indigenous peoples of Ecuador and the Global South, who steward lands that reveal treasures like this. Respect, collaboration, and equity are key to science. During the end screen, you'll see a playlist of community favorites. These are the videos you've watched and loved most this year, curated by our algorithm. If you're listening on audio podcast, check our show notes for links. We describe the visuals, provide the same interactive opportunities there, and transcripts for accessibility. From our digital hearts to yours, thank you for watching. Stay curious, stay kind, and we'll see you in the next adventure through time very soon.